SQA National 5 Maths 2014, Paper 2, Question 1. There are 964 pupils on the roll at Aberleven High School. It is forecast the roll will decrease by 15% per year. What will it be after 3 years? So it's going down by 15%. So if I start off with 100% and take away 15%, that gets me to 85%, which as a decimal is 0.85. That's my multiplier. So I take 964 times by 0.85, and then it's over 3 years, so to the power of 3, because this is depreciation. Calculator for that, 964 times 0.85 to the power of 3 is 592.0165. So I'll just write down my whole answer, 592.0165, which to the nearest 10 is 590. So I'll write 590 for my final answer. SQA National 5 Maths 2014, Paper 2, Question 2 on 3D coordinates. It says A is a point 846 with defined B and C. So let's just trace this out. There's A there. So that's at the back of the box. So B is also at the back of the box and just up the Z-axis. So that means that the first two coordinates will be the same. Let's just trace that out so you can really see that. If I go start from here, to get to B, I need to go along X to here, that's 8, in the Y to 4, and then up this distance, which is 6 plus something. I need to know what that something is, so let's read the question. It's a cube. So since I know that this is a cube, all the lengths are the same, so find one of the lengths, so going in the way is the same as that one. So I now know, I can take a note, that all the sides of the cube are 4. So that means that this is 4, and therefore B is 8, 4, 6 plus 4 is 10. So I've done B. So now let's look at C. Where is C? So C is, this is 4. So I need to go along till I hit it, and I know the whole length is 8, so it's in the middle. So I need to go along 4. It's at the front of the box, so I don't need to move in, so it's 0. And then I need to climb up the Z-axis. So I climb up 6, and then I climb up another 4, which is 10. So my answer is go along 4, don't go in the Y, so 0, and then go up the Z-axis by 6 and 4, which is 10, and I'm done there.
To solving simultaneous equations where you have to create the equations first for the worded problem. So let's start off with 2014 Paper 2, Question 3. Two groups of people go to a theatre. Bill buys tickets for 5 adults and 3 children. The tickets cost £158.25. Write down an equation. 5 adults, 3 children. 5 adults plus 3 children equal 158.25. Don't put any pound signs in your equations. You might even want to write A stands for adults and C stands for children, but you don't have to. Part B is very similar. Ben buys 3 adults and 2 children tickets, and the cost is 98. Write down an equation. 3 adults plus 2 children equals 98. We've now got 2 equations we can solve. So calculate the cost of a child and adult ticket for 4 marks, simultaneous equations. So let's go. So we just write down both our equations, one on top of the other. So we've got 5a plus 3c equals 158.25. And we've got 3a plus 2c equals 98. Remember, the goal is to make the a's the same or the c's the same. I'll make the c's the same. So I'm going to times the top one by 2 till we get 6, and times the bottom one by 3 to get 6. So that gives me 10a plus 6c. And this is a calculator question, you can see. So use a calculator whenever you need to. 2 times £158.25, £316, 316.5. And then 3 times 3 is 9a, 3 times 2 is 6c, and then 3 times 98, again you can use a calculator, don't be scared to use your calculator, but that's 300 minus 6, which is 294. Now, the signs are the same in front of c, so I can just take away. 10a take away 9a is 1a, equals 316.5 minus 294. Again, don't be scared to use your calculator. 16.5, 22.5. Now I'll just leave that as an answer there, but we're not done yet. We need to get our C. So substituting into any equation we've already used, I'll just use the top one. 5a plus 3c was 158.25. So we've got 5a plus 3c equals £158.25. So we've got 5 times 22.5 plus 3c equals £158.25. Getting our calculator back up. 5 times 22.5 is 112.5. Plus 3c is £158.25. Taking away 112.5, so again I'll get my calculator. £158.25 minus 112.5 gives me 45.75. So 3c is 45.75. Again, I'm not going to give myself a headache. I'm going to divide that by 3. Using my calculator, divide by 15.25 divided by 3. Now, usually, when we've been doing the ones before, we'd stop there and say, we've got 2 answers, an A and a C. We've solved it. But this is a question in context. It's calculated cost of a ticket for an adult and the cost for a ticket for a child. Well, 22.5 is not a cost, and neither is 15.25 because there's no pound signs. Also, we've not really defined what A and C are, so we need to be very, very clear with our answer. So always write a little statement at the end. Adult ticket equals £22.50. Child ticket equals £15.25, and we're done. If you don't like these statements, then you'll lose a mark.
The deviation to start with, SQA National 5 Maths 2014, Paper 2, Question 4 had this question. A runner has recorded her times in seconds for 6 different laps of a running track. These are the times. Calculate the mean, show clearly all your work in, then calculate the standard deviation, and then we have to compare a statement. So let's go through one step at a time. Part 1, calculating the mean. So just taking a note of these times. So for calculating the mean, we need to add all the numbers up and then divide by how many we've got. We get 339. So now the mean is equal to 339 divided by how many numbers we had, which was 1, 2, 3, 4, 5, 6. 56.5. Part 2 was calculate the standard deviation. So for standard deviation, usually I go with the formula sheet at the front equals the square root of the sum of x minus x bar squared all over n minus 1. Now there's another alternative formula you can use, but I always use this one. So the way this one works is you draw yourself a table and you call this one x, and then in the middle we get x minus x bar, which comes from the top of the formula, and then x minus x bar all squared. And x is all your data, so we've got 53, 57, 58. And then we've got 60, 55, and 56. And we need the mean, that's why part A calculates the mean. The mean is your x bar, so x bar is 56.5. So in the middle, you do each number take away the mean. And I'll quickly write these down. And then you calculate those answers. So 53 minus 56.5. And don't worry about getting negative answers here, that's completely normal because in the last column it says to square them, so we're going to square each of these numbers. So we times them by themselves. And then once we've got all our numbers, this symbol here means to add them all up, so we need to add up all our numbers and get a total here, and then that will replace the whole of the top line. So we get 29.5. So that means that our standard deviation equals the square root of 29.5, all divided by, and it says n minus 1, so that's 1 less than the number of numbers we started with, so we've got 6, so divide by 5, and again this is a calculator job. Square root, open brackets, 29.5 divided by 5, close brackets, 2.42899, or 2.4 to 1 decimal place. B says she changes her training routine to improve her consistency. After this change, she records her times for another 6 laps. The mean is 55, the standard deviation is 3.2. Has she improved her consistency? Well, the mean doesn't affect consistency at all, so we can ignore that. The consistency is all about the standard deviation. Remember, the smaller the standard deviation, the more consistent the results are. So we can say that she has not improved her consistency. Okay, so all you have to do is basically say that the standard deviation is bigger, so she's not improved her consistency. SQA National 5 Maths 2014, Paper 2, Question 5 on similarity. A supermarket sells cylindrical cookie jars which are mathematically similar. It shows us a cookie jars which has got a height of 15 and 24, and it says the smaller jar has a volume of 750. Let's take a note of that. The volume of this is 750 centimetres cubed. And we have to find the volume of the large jar. So this is using scale factor. For similar, you can use linear scale factor, then you can square it to get area, or cube it to get volume. Since we're doing volume, it's a cubed scale factor. So our volume scale factor, VSF, because I can't be bothered writing volume scale factor, is when I'm trying to find it in the big. So I start with the big side over the small side, 24 over 15. No need to simplify because you're using a calculator. But then we cube that because we're finding a volume. If you're finding a length, it would just be 24 over 15. Area would be that squared. Volume, it's that cubed. So then our new volume, the volume of our big bit, is simply the answer to this sum, which I'm not going to work out because I'm using a calculator, that cubed, times the smaller volume, which was 750. So now I get my calculator and work this out. So brackets, 24 divided by 15, close the brackets, cubed to the power of 3 times 750, and you get an answer of 3072. So that is 3072 centimetres cubed, and we're done there. Converse of Pythagoras. So this is when you're given all 3 sides, or you can know all 3 sides, and you have to work backwards with Pythagoras to see if it's a right angle or not. Let's have a look at some of these questions. You have to be very careful with these. So we have got the diagram below shows the position of 3 towns. It tells you all the information, but there's your diagram with the 3 sides. And it says, is High Town directly north of Low Town? Well, if it is, that means that that's east, which means that's a right angle. So when you're doing the converse of Pythagoras, you keep it all separate. So that's your left-hand side, and that'll be your right-hand side. Well, your left-hand side would be 85 squared plus 75 squared. And your right-hand side would be 110 squared. Do not write that those are equal. You do not know if they're equal yet. You're trying to check if they are. So you get both of them down, but it's completely separate. You then evaluate or work out them both. So the left-hand side, 12850. And the right-hand side gives you 12100. Now, they're not equal. So then you can compare and say, well, if this plus this equals this, it is a right angle. But if this plus this does not equal this, it is not a right angle. So we just have to write that down. since 85 squared plus 75 squared does not equal 110 squared, not a right angle, therefore High Town is not north of Low Town. And there we are. First volume question, SQA National 5 Maths 2014, Paper 2, Question 7 had this one. An ornament is made in the shape of a cone with diameter of 8 and a height of 15. The bottom contains a hemisphere made of copper with diameter 7.4 centimetres. The rest is made of glass. Calculate the volume of the glass part of the ornament. Give your answers correct to two significant figures. So this is our glass part and this is our copper part. So we need to work out the volume of the cone, then the volume of the hemisphere, and take that away to get whatever's left in the glass bit, because the glass bit only goes up to here, it's not the full cone. So let's start with that. So for our cone, we go to the start of the exam paper and write down the formula for the volume of a cone, which, remind you, is 1/3 pi r squared times h. So that's 1/3 times pi times, and then the radius of our cone, well, the cone's radius actually is given here. The diameter is 8, it told you in the question, so the radius is 4. So it's 1/3 times pi times 4 squared times the height of 15. And if you put all that in a calculator, you get 251.32 with a bunch of other numbers, so that's centimetres cubed. So we've done our cone, now we need to do our hemisphere. So the volume of our hemisphere, well, it's going to be a half of a sphere, so that's a half times 4/3 pi r cubed. Pi. The radius is half of the diameter. The diameter we can see is 7.4, so that's 3.7 cubed. So you get a mark here for doing 4/3 pi r cubed, and then you get a mark for half, and then half in it as well. So we get 106.08 when we do all that. Centimetres cubed. We've got two answers. Now we need to remember it's a takeaway. We're doing the whole cone minus the hemisphere. So the volume of our glass part, I suppose we could say, because it is about the glass, is 251.32 with a bunch of numbers minus 106.08. Now when I say a bunch of numbers, I'm just taking the numbers in my calculator minus the numbers in my calculator. I'm not rounding at this point. That's what the ... signifies. So we get a mark for doing take away, and we get 145.24. And then we need to check if we have to round the answer. Round your answer to two significant figures. So that means I need to round 1, 2, cut here. So I get 150 centimetres cubed to two significant figures. And we're done there for our 5th mark.
Very simple past paper question here. This is from 2014, paper 2, question 8. So it's a calculator question, even though you probably don't need it. So you've got simplify n to the power of 5 times 10n over 2n squared. So that is the same as n to the power of 5 times 10n, well, that's a power of 1 over 2n squared. So let's just deal with the top and bottom separately. So doing the top, we've got 10n6. Add the powers over 2n squared. 10 divided by 2 is 5n, and I can take away the powers now. 6 minus 2 is 4. 2014, paper 2, question 9. It says express 7 over x plus 5 minus 3 over x as a single fraction. We're adding fractions. So here's our fractions. Common denominator, just times the denominators. Then we can do the first one times x, and the second one times x plus 5. So putting that together, on the top, we're going to get 7x minus 3, bracket x add 5, because we're timesing the whole thing by x add 5. And in the bottom, x, bracket x add 5 again, because it's x times x add 5. Now we can multiply our we can multiply out our bracket on the top. So we get 7x minus 3x minus 15 over x add 5. Simplifying the top is 4x minus 15 over x add 5. And we're done.
2014 paper 2 question 10 was in a race, boats sail around the three buoys A, B and C in the diagram below. B is 8 kilometres on a bearing of 60 degrees. C is 11 kilometres from B. A is 13 kilometres from C. And the first part of the question is calculate the angle ABC. So they've given us a diagram in this case, so we can just get started straight away. A to B to C. It's this angle in here. So just take a little note of that. That's this one. And if we just check, if we're given three sides of a triangle, and we can always calculate an angle using the cosine rule if we already know all three sides. If we have opposite pairs, an angle on a side, and then maybe a side, and we're trying to find the missing angle, that would be the sine rule. So in this case, it's the cosine rule. So a reminder from the start of the exam paper. So cos A equals B squared plus C squared minus A squared over 2BC. Now, there's a couple of ways to think of this. When they say cos A, they mean the angle you're looking for, we're calling A. But in this case, there's a B attached to this, so don't get too confused. It is always, the angle, the one you take away, is always opposite it. So 13 is my A here. If you want to avoid confusion, you can draw yourself a little diagram, like so, and go, right, I'll call that A because that's the angle I want, and then my 13 is my little a. Then the other two sides would be B and C, so that would be B at 11 and C would be the other side, which is 8 kilometres. So we can say that the cos of our angle equals 8 squared plus 11 squared minus 13 squared over 2 times 8 times 11. And you would get a mark at that point for substituting in. And then we need to work this out. So cos A would equal, using a calculator, you would do 8 squared plus 11 squared minus 13 squared, get an answer, then divide by 2 times 8 times 11, making sure you're using brackets, and you would get 0.09. With a bunch of other numbers. So then to get an angle, we need to do the inverse cos. So the inverse cos of 0.09 equals 85 or 84.8. So 85 degrees would be a reasonable degree of accuracy. Or if you got 84.8, that would be fine. So just to answer the question, remember they said angle ABC. I would then write, to be very clear, angle ABC equals 85 degrees. And we're done there. So now for part B says, hence find the size of a shaded angle. Well, we've already worked out that now this is 85 degrees. And it says find the size of this angle here. So we're going to use some angle rules. We know from the previous example that I did before that if you've got two north lines, the angles inside those north lines add up to 180. So I can immediately just diagram do 120 there, because 120 plus 60 is 180. And our second rule, we often use angles round a point add up to 360. So we can do a bit of work and say 120 plus 85 degrees is equal to 205 degrees. So we get 360 minus 205, which gives us an answer of 155. Obviously, if you kept your answer as 84.8 for part A, then you would write 155.2 instead. One mark for working out what you need to take away from 360, and the final mark for calculating it, of course.
14, paper 2, question 11. So this time we have to change the subject to A, but there is a fraction. So I'm going to times everything by 2. So being very careful, but note this down. This will get times by 2, but so will this one, and then so will this one. So we end up with 2s equals 2ut plus 2 times a half is 1, so just at squared. Now we have to change this up to a, so taking away the 2ut, because that's not got any a's in it, we get 2s minus 2ut equals at squared. And then dividing by anything attached to the a, so the t squared, we get 2s minus 2ut all over a squared equals all over t squared equals a, or to write it round the other way, a equals 2s minus 2ut all over t squared. And we're done there.
Trigonometric equations, SQA National 5 Maths, 2014, paper 2, question 12 had 11 cos x minus 2 equals 3 for x between 0 and 360. So let's go through this in depth. We want to make cos x a subject and solve it, and then we need to find the related angles using a cast diagram is what we normally call it. So let's start off working on this. If I take 11 cos x, if I add 2 to both sides, that equals 5. Divided through by 11, cos x must equal 5/11. So x is the inverse cos of 5 over 11. And this is a calculator job. You're not going to do this without a calculator. So you go to your calculator and you type in the inverse cos of 5 over 11. That gives you 62.96. So we'll just round that to 63 degrees. But that isn't our only answer, because you can draw a cast diagram to find your related angle. So you'd always start on the bottom right and then go anti-clockwise. In this quadrant, it's 180 plus the angle. This one is 180 minus, and this one is 360 minus. Now, to work out which you've got, you need to check, was your original thing positive or negative? Well, 5/11 is positive, so I tick A if it's positive, and you always then tick the one you've got, which is cos. If it was negative, I would just tick the other two. So I now need to do 360 minus 63 degrees to get our second answer, which is 297 degrees in this case. So 2014, paper 2, question 13. We've got, the picture shows the entrance to a tunnel, which is in the shape of a part of a circle. The diagram represents the cross section, and it says the centre 0. You've got the angle 50 degrees. You have got, this is 7 metres. Calculate the area of the cross section of a tunnel. So this is quite a long, hard one to start us off with. You've got to calculate the area of the arc and then add on the area of the triangle, which is using trigonometry. So check my previous videos on that, half AB sine C. Let's start off with the area of the arc though. So area, remember, equals angle out of 360 times pi r squared. So this time be very careful, our arc is going this way. So that is going to be 310 degrees, because 360 minus 50 is 310. So 310 over 360 times pi times 7 squared. We get a mark for knowing the angle, and then we get a mark for working that out, which is 132.56 centimetres squared. So we've done our arc bit, but we now need to do our triangular part. So our triangle bit is a half AB sine C. So for the triangle, I'm using the start of the formula sheet, a half AB sine C, where C is the angle and A and B are the lengths either side of the angle. So it is 0.5 times 7 again, times the sine of 50. Doing that in a calculator, we get 18.77 square centimetres. So then our total area, we've got 2 answers so far for 4 marks. Our total area, so that's 3 marks. We get a mark for knowing we need to add to get our total area. So 132.56 plus 18.77, which gives us a final answer of 151.3 square centimetres.